Okay, let's get this test reviewed here quick. Test 5, talking about compound angles. Problems 1 through 3. We're looking at a block, something like this. 1.2 inches here, 1.4 there, 2.4 inches down here. And we're dealing with a corner-to-corner cut of some sort. We're asked to find angle of rotation. We're asked to find angle A down here. It's not necessarily the angle of tilt, it's a lower angle. And we are asked to find the length of the cut. Angle R is easy to find. What is angle R? Yeah, it's the inverse tangent of 1.4 over 2.4. It's not 26.57.
For R, 26.33.
Number 1. Should be 30.26 degrees. That's angle R. Did you have 30.26? Okay, well, make the change and I'll change it when you do your turn your corrections. Apparently I was drinking when I graded one of your tests.
I'll change it.
Oh, you're right. It should be 26.57. What am I doing? That's why it's marked wrong. This should be 1.2 here, not 2.4. Sorry about that. Drew earns his lollipop for the day. So, the length of cut is the square root of 1.2 squared plus 1.4 squared plus 2.4 squared. Which, if we work that all out, well, it should be 3.026 or 3.03 inches. Now that we have that length of cut, A can be found by, you know this length here and you know this opposite side. So A is going to be the inverse sine of 1.2 over 3.03, which should give us what? 27.55 about. There we go. So there's 1, 2, and 3 for you. Questions, complaints, arguments? Okay. Moving on then to 4 through 6. On 4 through 6. We're still looking at that corner to corner there. We're asked to find angle of rotation here, angle of tilt up there. And what we are given is that from this angle, or from this direction, this is a 44-degree angle here. And from the end view, this is a 12-degree angle here. And we are actually given a thickness here of 0.9 inches. Because we're given a thickness, we can find a length of cut on this. So let's go ahead and find what we need to. We're going to find this dimension here, call that x, which is actually this dimension here as well. This dimension here is y, which is actually this dimension. The 0.9 is right there, the thickness. So to find x, according to this angle, that's the opposite side. So tangent of 12 degrees is opposite over adjacent. So x is the opposite, 0.9 is the adjacent. So to find x, put this over 1, cross multiply and divide. So tangent of 12 times 0.9 gives us x. 0.1913.
Number 4 was a homework question.
Yeah, I know. I try to be nice every now and then. This one's tangent of 44 degrees equals y over 0.9. Put it over 1. I also did number 4 in class the day before I gave you the test. Cross multiply and divide is tangent of 44 times 0.9 divided by 1. We don't need to divide by 1. So 0.8691. So 0.8691 is the length there. So now to find r, angle of rotation is always an inverse tangent. This side over here is the 0.1913. This side here is 0.8691. So second tangent, 0.1913 divided by 0.8691, close, is 12.41 degrees. Length of cut is the square root of 0.9 squared plus 0.1913 squared plus 0.8691 squared. What do we get with those? 1.266. Good. And now that we have that length of cut, we know the height here. So T is going to be, A here was down. Since A was down here, we had the opposite side in the hypotenuse. That's why we used cosine. But since T is this angle up here, we have adjacent side and hypotenuse. So we're going to use inverse cosine. Adjacent is cosine, opposite was sine. So T is going to be an inverse cosine of that thickness of 0.9 over the length of cut of 1.266, which should come out to be 4469 degrees. So again, number 4, number 5, and number 6. Questions?
We usually carry our decimal places out to 3 places when we're.
For lengths, usually 3 places. Angles, usually at least 2. Because remember, you guys are always machining to 1/1000th of an inch, usually. Okay, 7 through 9. I'm just going to take the relevant information off of here. I realize my drawing here sucks. Okay. So you're asked to find R, T, and the length of cut again. You're given. It's time for a new vehicle if you get tracked down by a guy on a cop on a bicycle. Let's get back to this one. Okay, now, so on this one, you can see I just took the dimensions out of there and I put them onto the piece. So our rotation here, R, is going to be the inverse tangent of what? 0.4 over 0.4 would be this one. This one, of course, will be 1.2. That inverse tangent comes out to be 18.43 degrees. Next, I want to know the length, which is the square root of 1.0 squared plus 0.4 squared plus 1.2 squared, which is 1.612. Did I do that wrong? That doesn't look right.
So that's what I got. 1.612.
That's right.
Are we at 7?
Yeah.
Oh, well, yeah, that's 1, 2.
I put the numbers in there wrong somehow. I'm getting 1.265. 1.265 looks right, doesn't it?
You got time between your 4 and
Ah, that's what it is. Okay, we'll go with 1.612. There you go. Sure, yeah, say that for me. Thanks. So T is going to be an inverse cosine. We know this here is the 1.0, and the hypotenuse is the 1.612, which should give us 5166. A lot of you had the tilt wrong, but I think that's because you did inverse sine instead of inverse cosine, and you would have got the complement, which would have been the 38.34 or something like that. So there is 7, 8, and 9.
So we should just take this exact same test for end of the year.
Not quite. We gotta do a little bit different. Next one. Ten and 11. So what we're doing is we're cutting out this corner like this to machine off a flat surface. If we're looking at it from the end here, this is a 23-degree angle. Or from the side, I should say it's 23-degree angle. From the end here, it is a 31-degree angle. Here we are not given a depth, so you can choose whatever you want. Oh, I'm sorry. It should be 18 and 30, shouldn't it? 18 and 30. There we go. That look better? So here we are not given a depth, so I'm just going to choose 10 millimeters. And we're going to go from there. This I'll call X here. And Y. If I'm looking at it from the top, here's X, here's Y. X is going to be found tangent of 30 degrees. The opposite side is now the 10 millimeters. X goes on bottom, so we put this over 1. Cross multiply and divide, it becomes 10 divided by tangent of 30.
You want to put X over 10?
Should be 10 over X. So it's 17.32 is X. Because here, if this is the angle, 10 is the opposite. Opposite goes on top. X is the adjacent. On the other side, it's tangent of 18. The opposite side is the 10 millimeters. Y is the adjacent. So you put it over 1 and cross multiply and divide. So 1 times 10 is 10 divided by the tangent of 18. Gives us 30.78. So our angle of rotation is right here. What's that? 30.78 we get there.
So that's where we screwed up last time.
Yep, I had those upside down. I told you there was one I screwed up, but I wasn't going to tell you which one. That's the one. So R, the angle of rotation, is the inverse tangent. 1732 over 30.78, which comes out to be 29.37 degrees.
So if I would figure that with the inverse sine or inverse cosine, that would come up with complement to that.
No, this one, if you did inverse cosine, it wouldn't have worked at all. You'd have came up with something totally unrelated. If you flipped these over, if you put this one on bottom and this one on top, you would have got the complement. Now remember, we got to find this length across here, which is actually this length here. That is going to be found by using a sine. Sine of R, which is the 29.37 degrees, is going to equal that length. I'm going to call it Z over the 30.78. So to find Z, it's 30.78 times the sine of 29.37 degrees. So at 15.10 basically is what that Z is. And now our angle of tilt is this angle right here. That angle involves this dimension we just found, this depth of 10 millimeters. This is 10. This is the 15.10 that we just found. And this is our angle of tilt. So T is going to be an inverse tangent of 10. The 15.10, we knew this was 30.78 here. We found this angle. 15.10 is this across here at a right angle. So T comes out to be 3350. Yeah, 3351, 3352, somewhere in there. And 13. So what we have here, if I'm looking at this from the front, this cutoff angle here is 23 degrees. Looking at it from the end, this cutoff angle here is 31 degrees. I need to know R and T. R, if I'm looking at my box. Wow, that's sloppy. R is still this. We're using T is down here this time. I do not give you a depth, so we can choose whatever we want to. So let's choose 10 millimeters. We got X and Y here. We're going to find X and Y the same as we did before. Tangent to 23 degrees is going to equal to 10 over Y. Should give us 10 divided by tangent of 23. Give us 2355, 2356 here. X is going to be the tangent of 31 is going to equal 10 over X. So it's 1 times 10 divided by tangent of 31. So 10 divided by tangent of 31 gives us x. So that's 16.64. This depth, of course, is 10. And now this is just like many of the problems we've done before. R is going to be an inverse tangent of 1664 over 2356. Otherwise known as 35.24 degrees. T needs a little bit more work. For T, we need to do a hypothetical length here. That length will be the square root of 10 squared plus 23.56 squared plus 16.64 squared. Giving us 30.53. That would be the length of cut here, or length of the edge in this case. So that T is equal to, now T is down here, so this is an opposite side in hypotenuse, so it's going to be a sine. So it's an inverse sine of 10 over 30.53, which gives us what? 19.12. Works for me. A couple here and there, huh? 14 and 15. Requires just a little bit of calculation to start it out, and then it's not bad from there. You're given that this dimension here is 0.4 and this is 0.8. And you're given the full dimension of 2.2 and 1.3. All you really care about is this box here. So this piece here is 2.2 minus 0.8, or 1.4. This piece here is 1.3 minus 0.4, or 0.9. In the next picture over, we're given a depth. We're given 0.75 here. We don't give a crap about that. We're given 0.6 here. That's what we care about. So here's our surface again. This is 0.9, this is 1.4, this is 0.6. Here is R, here is T. I'm going to let you guys do that one on your own. That can be your little bit of homework for the last 15 minutes.